revision videos for O-level students. Now, this is about movement of a force. Movement of a force movement of a force means turning effect of a force. Movement is also known as turning effect. Now, look at this diagram now. Now, this is an object, say a metal plate, or actually a plank of wood. Now, this can be rotated around this nail. Around this nail, you can rotate this by applying force. When you apply a force to this will rotate. Or you can say it turns. Therefore, this is known as turning effect of a force. Now think, you are applying a force of 10 newtons to this object. Now you are applying a force of 10 newtons to this object. Now this dotted line shows the line of action of this force. Line of action of this force of 10 Newton is this actually. Now, this is the nail. Actually, it is the axis now. Now, this nail is the axis of rotation. This is rotated about this now. Now, 0.4 meters is the perpendicular distance. This is the perpendicular distance from the axis of rotation to the line of action of the force. Now, this 0.2, what is this 0.2? Half of this actually. Now, if we apply this force, the same force, actually at this point, see this is A, this is B. When you apply the force at A, now see the difference. When you apply this force at A and when you apply the same force at B, actually movement or the turning effect is more when you apply the force at B. The reason is this distance is actually more than this. This is greater than this. So therefore, to calculate the movement or to calculate the turning effect, you have to consider about the distance also, not only the force. Actually, by the force only you can't decide that. You must know this distance also. Therefore, when you multiply, now movement is equal to force into now this distance, perpendicular distance. When you multiply these two, you will get 4 Newton meters. Now this is the movement or turning effect of this force, turning effect or the movement of this force about this axis, about this axis. Now, when we apply this force actually at B, let us calculate that also. Movement, now, movement, this is the movement when we apply the same force, 10 newtons, at B. 10 newtons into 0.2 meters, that is 2 newton meters. 4 newton meters when we apply at this point. For 2 when we apply the force at B. 4 newton meters is the moment when we apply the force at A. Now this is actually greater than this. The reason is, now this distance is actually greater than this. When this distance increases, moment also increases. So therefore, not only the force, you have to consider about this distance also. What sort of distance? Perpendicular distance. Therefore, you can actually calculate the movement by multiplying the force by the perpendicular distance from the axis or the balancing point or the axis actually to the line of action of the force. If you apply force here, this distance 0.2. If you apply the same force here, then 0.2. So therefore, movement is equal to the applied force applied multiplied by the perpendicular distance from the line of action, from the pivot or from the axis of rotation to the line of action of the force. So you can calculate the movement by multiplying these two FD. Now, sometimes you are given, say, a rod, metal rod, say AB. Now this is a metal rod. You can actually name this as AB. Uniform rod. This is its midpoint. Say the length of this rod is 1 meter. Here you have 0.5. This length also 0.5. Now this is actually a force applied at the NB, say 12 newtons. If a force of 12 newtons is applied at B, what should be the moment produced due to this force? That is, actually this movement is actually to the right side, no? Therefore, you can actually name this as movement clockwise movement. Clockwise movement is equal to 12 newtons multiplied by 0.5, 6 Newton meters. 6 Newton meters. Clockwise movement. Now say you apply the same force here at A. It is actually anti-clockwise movement. Anti-clockwise movement is equal to 12 newtons into same force, same distance, same movement. And here, clockwise movement is equal to the anti-clockwise movement. Therefore, this is in equilibrium. An object will be in equilibrium if the clockwise movement is equal to the anti-clockwise movement. Now, if you apply the same force, if you apply say a force of now not the same force, we'll assume this to be x. Now this is some force, you have to calculate it and see. Now what should be the force? What should be this force needed or required to keep this in equilibrium? Now this distance is equal to say 0.25. Now this distance is 0.25 meters. What should be the force that should be applied at this point? This is actually now distance between these two 0.25. Now here clockwise, now this should be actually, we apply this force to keep this actually in equilibrium. To keep the body equilibrium, the two actually movements, clockwise and anti-clockwise movement should be equal. Now here anti-clockwise movement is x multiplied by 0.25. Clockwise movement is equal to 12 into 0.5. This will be in equilibrium if these two are equal. Therefore, x multiplied by 0.25 is equal to 12 multiplied by 0.5. Therefore, x is equal to, now here you have to calculate the force that should be applied to keep this in equilibrium. X is equal to 12 multiplied by 0.5, divide this by 0.25. Actually 0.5 is twice than this. Therefore 12 into 2, you need 24 Newton. And actually now you can think the reason for this. Here distance is actually half of this. Here the force is actually, and here it is actually 24. You need more force. You need more force because the distance is actually half of this. So you have to think all these actually. Now this also about movement. Now in the future, when we are actually doing papers, so more questions from this area, from this unit also we will do more many questions as much as possible from this unit also in the future. Now ask your friends also to use these videos and learn, and do not forget to subscribe my YouTube channel.